There are many different ways of proving in math. Proof by contradiction, proof by contraposition, the list goes on and on. But this video will be talking about one specific type of proving, namely mathematical induction. So what exactly is mathematical induction? Mathematical induction is the process of formulating a general result from a close examination of the simplest cases. What? Let me explain this principle using a stack of dominoes. Well, let's say that this series of continuous, infinitely long dominoes is our proposition or conjecture. It's an unproven statement that we believe is true. Now, just like how each domino only falls when the domino before it falls, in induction, for each expression to be true, the preceding expression must be true. Using the Stallman Analogy, we can conclude that when all the dominoes fall, hence all the expressions are true, our conjecture would be proved. However, as you can see it, if there was even one expression that was not true, the dominoes after it would not fall. Thus, our proposition would be disproved. So how do we know whether the expressions would be true or not? Let's use this conjecture as an example. The sum of the first n odd numbers equals n squared. To prove this is true, we just need to show that the left-hand side is equal to the right-hand side. But to prove that a proposition would work from 1 to infinity would take way too much time. So for this, we can use 4 general steps of induction. Step 1 is that the initial value, often when n equals 1, must be true and equate each other. This is essentially finding out whether the first domino of the stack will fall. If it doesn't and the two expressions don't equate each other, we can immediately say that a proposition is untrue. Here, since both the left and right hand sides equal each other, we can see that the first domino of the series will indeed fall. Step 2 is assuming that our general proposition is true. In other words, by replacing n with k, some random integer, we're assuming that some dominoes in the stack will fall. Step 3 is proving that its following expression, specifically when n equals k plus 1, is true. Essentially, we're proving that the next domino in the series will fall. Here, we can rearrange the equation using our assumption in step 2 to prove that the left-hand side equals the right-hand side, proving our conjecture true. Step 4 is the conclusion. If the initial value has been proven to be true, and our assumption of when k and k plus 1 has been proven true, then we can say that our proposition is true. As such, thanks to mathematical induction and thanks to the early contributions of mathematicians such as Pascal and Euclid, we are now able to verify our conjectures without having to prove them from the first domino to the last domino.